Hey everyone, today I'm going to be teaching you about graphs and how to generate mazes like this one that's generating now. As you can see, it's going through the maze, it's creating it as it goes through each little spot, and then it returns back to the start at the end. And this green pointer tells you where the maze is generated. I'm going to go over how you approach a problem like this and use graphs. I'm going to introduce you to graphs, and then we're going to look at different algorithms that allow you to solve this. Now in the showcase here, we have this maze that was generated, and each time it generates, it will be completely random. In the program itself, we are able to change many different things like the height of the maze and the width of each cell and the width of the board or the maze board. So let's say I want to create a different maze. I want the height to be 30. Let's have a really tall maze. So this is just another random maze. As you can see, it's going through generating the maze as quick as possible. I do have a little wait delay to allow you to see what's happening, but everywhere where it's white is where it's visited. And from the previous one, you can see that it is taller. So just by playing around with this, you can change the kind of look of the maze. Another thing you can do with this as well is change the thickness of the walls. So at the moment it's 1. We can change it to 0.1 if we want. And now each wall is really thin, only 0.1 in stroke. As you can see now, it looks really thick. The walls are really thick now. And as you can see, it's kind of building on the maze as it goes round. Now, how would you go about creating something like this? Well, I'm going to introduce you to graphs today, and then we'll look at 3 algorithms that can program this, and I'll show you which one I used to program this. All the programs I used in this, if you want to copy the maze generation program, will be in my Discord server, linked in the description. But I'd probably stay around to understand the theory behind it, just in case you want to add on to this to have like an exit and an entrance to the maze, because at the moment it doesn't have any of that. This is just to show you and introduce you to graphs. So to program something like this, we need to introduce you to graphs. Now, graphs consist of nodes and edges, and you connect them together to create trees or cyclic graphs. And there's different examples here on the screen, and we can actually represent our maze like a graph. Now, a maze is made up of blocks or cells, and each cell will contain its own data. Now, the data that this cell contains is up to you, but the main stuff that needs to be in there is stuff like its neighbors and where it is on the board. But each cell will have its own information. Now, when it comes to generating mazes, a maze can be represented like a graph where each cell will have an edge connecting to its neighbor. And remember, an edge is just a line that connects 2 nodes together. Now, there's 3 algorithms that I want you to be aware of before we talk about the one that I use to code this program. There's Prim's algorithm, Kruskal's algorithm, and the backtracking algorithm, or the depth-first search algorithm. Now, for this example, I use the depth-first search algorithm. Kruskal and Prim's algorithm, what they use is they use the minimum spanning tree to create a maze. And a minimum spanning tree is the minimum number of edges needed to connect each node at the lowest cost. So for example, if you had this graph here, this would be the minimum spanning tree for that graph. But there's also this one that it also could be. It will all depend on the weights of the edges. And a weighted edge just means that it has a number associated with it. So the edge going between node 1 and node 3 here would be lighter than the edge going from node 1 to node 2 based on its weight. However, I use the depth-first search algorithm or the backtracking algorithm. And backtracking is basically you go down so far and then you may need to go back, so you backtrack back to the previous part. You'll actually see it happen here actually. As it goes up here, it's going to backtrack to where it's already been until it reaches an available spot. And then what the pointer does is it will choose a random neighbor to move to. So as you can see, this is completely random what it's doing here. And this is all completely random. It picks a random neighbor and chooses that. However, what it can't do is it can't go back to a previously visited node. So if the neighbor has been visited, it won't go back to it. And this is what the program does. And it uses a stack to keep track of where it's been. Every time it passes a current node here, it will add it to the stack. And if it needs to backtrack, it can backtrack all the way back to the start. All of these nodes that are in white have been recorded in the stack. So this allows for the backtracking to take place. It allows it to move back until there's an available spot that it can go into. So this video really was to make you aware of Prim's and Kruskal's algorithm and also the backtracking. There's a lot more graph things that we can do, but this was a showcase of an algorithm that allows you to create mazes. As I said, all of this will be linked in my Discord server. If you join that, you'll be able to access all the scripts. You'll be able to add mazes yourself. It'll be easy to add coins, add stuff like that. The code itself contains a server which basically just creates the maze, creates the grid. It will allow you to remove walls between 2 nodes, and it will also calculate the maze for you. This is the main loop, this function here. This basically checks that the stack is not empty, and it will just continue running until it's done. The node class, however, allows you to create a new node with all its data stored inside. It allows you to change the colors of the walls. You can spawn the 4 walls. We have the top wall, the left wall, the bottom wall, and the right wall. In the program itself, each cell is made up of 4 walls. As you can see here, these are the 4 walls. The calculate stack node index just allows you to check neighbors, and this checks check neighbors function will basically check the bottom, left, top, and right node to see if it's an available neighbor. And then in the main script, it will choose a random neighbor from those set of neighbors and it will move to that neighbor. But that is it for programming mazes in Roblox Studio. It's fairly straightforward. You just need to follow the algorithm. All sources that I use for the video will be in the description. There'll be an RBXL file in the description as well with this on. And you can also join the Discord server to get links to all the scripts that allow you to create this maze. So for example, if you want to use this in a horror game and have a horror game that allows you to walk around a maze, then definitely use this. Yeah, I'll be sharing more algorithms and tutorials for different unique stuff like this. Put in the comments what other algorithms and tutorials you'd want to see. The comment to today's video from the previous video is by Exonerate, and he said, nice video as always, you're doing great. I do appreciate every comment and I'll try and respond to all of you that comment down below. If you do find this programming showcase useful and actually use the script in your own Roblox games, then obviously please leave a like. That's all I ask. My channel is small and I'm trying to grow, so hopefully I'll see you in the next Roblox Studio tutorial video. Thanks for watching.